Assalamu alaikum everyone. In today's video lecture, we'll learn about NMR spectroscopy, its application, and structural elucidation. So let's start. So what is NMR spectroscopy? Nuclear magnetic resonance spectroscopy, commonly referred to as NMR, is a technique which exploits the magnetic properties of certain nuclei to study physical, chemical, and biological properties of. Compared to mass spectrometry, larger amount of samples are needed but non-destructive. So NMR is a spectroscopic method that is more important than IR. Many nuclei can be studied by NMR techniques, but hydrogen and carbon are most commonly studied. IR reveals the type of functional group present in the molecule, whereas NMR gives the information about the number of magnetically distinct atoms of the type being studied. That means NMR gives us full idea about the structure of any chemical compound, whereas in IR, UV spectroscopy, or atomic exhaustion spectroscopy, or fluorometry, we just uh, see the different functional groups, or we define the concentration, but in NMR we actually get the overall structure. When hydrogen nuclei are studied, for instance, one can determine the number of each of the distinct types of hydrogen nuclei, as well as obtain information regarding the nature of the immediate environment of each type. So similar information can be determined from the carbon nuclei. The combination of IR and NMR data is often sufficient to determine completely the structure of an unknown molecule. So this slide shows the overall history of NMR. You can see how step by step development of NMR has been performed. Nearly a dozen of Nobel Prize has been given on NMR. In 1944, in physics, Rabi obtained Nobel Prize. Then in 1952, Bloch and Purcell. Then in 1991, earned Nobel Prize. Then in 2002, Utrecht won Nobel Prize. In 2003, in medicine, uh, Lutherberg and Mansfield achieved Nobel Prize. So here is a schematic diagram of NMR spectrometer. Like other spectrometer, it contains some detector, recorder, then sample compartment. However, the main difference is that it contains powerful electromagnetic or superconducting magnet, and it differentiates NMR from any other spectroscopy like UV, atomic exhaustion, fluorometry, or IR spectrometry. Notable thing is that in NMR we usually use radio frequency. In UV spectrometry we used UV spectrum, then in IR we use infrared spectrum. Okay. uh, then in fluorometry we used also UV. In X-ray diagnostic technique we use X-ray. Okay, but in NMR only uh, low frequency wavelength, that is a radio frequency, is enough to cause the transition. Okay, the to cause a shift. So we'll see the overall principle below. Actually, how NMR works, you can see here. First of all, nuclear spins are random. In any sample, usually spins are in random places or random direction. Okay, but whenever applied field is given, then they arranged in aligned or in opposite field. Okay, whenever they are opposed with the applied field, that is called the alpha spin state, and whenever they are aligned with the applied field, then beta spin state. Actually, whenever we apply magnetic field, then the spin are either aligned or opposite to the applied field, but they are not non-directional. They are unidirectional but can be in aligned or opposite. Okay, but they are not disorganized. So to clearly understand this, just compare with that scenario. Just think a teacher as applied field and students are the spin of electrons. So whenever in any playground no teachers are present, then students are randomly aligned. You can see they are randomly aligned. Okay, no orientation. So whenever in the PT, physical training, uh, in our school, we all of us has passed this actually. uh, Whenever teachers are present, then you can see all of the students are aligned in one direction. Okay, actually these students just think these students as the spin of electron, and the students are applied magnetic field, so they are magnet. So in the presence of teacher, actually what happened to those electrons? In the presence of the applied field, all of the spins are aligned. Okay, aligned with the applied magnetic field. And you can say, uh, and this phenomenon is also called resonance, because your teacher will motivate you, will say something to you, and this will create some chemistry between you and your teacher. Okay, and in the presence of applied magnetic field, actually this resonance happened. So this is the basic theory of uh, NMR. Just think another case. Suddenly these teachers are has gone to their room. Okay, then what will happen? Then a student will again disorganized to that position. So this is the overall concept. Whenever we are applying the magnetic field, then actually the electron is organizing in aligned or opposite to that of magnetic field, based on their uh, uh, availability of hydrogen, or based on their chemical structure. Okay, so this is the basic concept of NMR. Just if I put the basic concept uh, as a principle, you can easily understand that NMR is based on the interaction among the nuclear spin, an external magnetic field, and a radio frequency radiation. When spin active nuclei are placed in external magnetic field, they align themselves. You can see uh, they have aligned themselves in different energy states according to their spin quantum number, and start to process to a specific frequency. So what is the frequency? It depends on their chemical structure. Okay, so how the students will treat their teacher, or how they will get organized upon the integration of the teacher, actually depends on their mentality, and also depends on their behavior or attitude towards their teacher. And actually this happens to them. How the spin will organize in different frequency will actually depend on their nature. Okay, and also between the interaction of the applied field and the spin. This precessional frequency is directly proportional to the strength of the magnetic field. Okay, so how if the teacher is very strict, then their alignment would be very good. The effective magnetic field a nucleus experiences is influenced by its chemical environment, including the type of nearby atom and the bonds they formed. Resonance occur. You can see the resonance. So this is the main thing. Resonance occurred when the frequency of the nuclear procession matches the frequency of the radio frequency electromagnetic radiation. So whenever teacher's mentality is just aligned with the student's mentality, then there is a very good chemistry happens between them. So this resonance causes the nucleus to absorb energy. Obviously, if the students feel very motivated from their teacher, they will also absorb his talkings, his motivations, or his speeches, moving them from lower energy state to higher energy state. Okay, when the nucleus returns to their lower energy state. So when it happens, actually suddenly the teachers came to his room, then the nuclei will again come to their lower energy state, and they release the absorbed energy as radio frequency signal, which is detected by the NMR spectrometer. And so this is the basic scenario which is actually seen in any other spectrometry. Actually this phenomenon is also observable in UV spectrometry, IR spectrometry. Okay, so this is the overall concept of NMR spectroscopy. And by detecting the uh, chemical shift or spin or the nature of the signal, we can easily detect the overall structure of the compound. So actually what information we get from the NMR spectroscopy? So this is very important. So these four informations can be generated from the uh, NMR spectroscopy, like number of the signals, then position of the signals, then relative area under signal, that is called integration, and the splitting pattern. So to uh, actually how we can remember this, you can remember the word spin. So S means splitting, P means position, I means integration or intensity. Okay, and N means number of the signal. So if you can remember this, you can easily remember the trick, you can easily get idea actually what information we make it. Actually this four information can be found from NMR spectroscopy. So what the number of the signal means, it actually means how many different types of hydrogens in a molecule, and the position of the signal means what type of hydrogens. Okay, that is also called chemical shift. Then intensity, what does intensity or integration means, it means how many hydrogen of each type. And splitting pattern, how many neighboring hydrogens. So it may be very difficult to understand this, just follow my following slides. First of all, number of signal. Okay, how many different types of hydrogens in a molecule. So to understand this, first of all, think that, so how many signals can be found from here. Actually these four hydrogens are of similar type, so one signal. Then CH3 CH3, obviously these six hydrogen are of similar type because there is no variation, so one signal. So here it will be one signal because all of the hydrogen are in similar environment, so one signal. So here is also one signal, it is benzene. Okay, you will find one signal. So one signal means one spectrum. In SPLC we have seen, if you get one signal, one peak, then that means there is one signal or one compound. Okay, here also one signal, because yeah, you may think that there is four hydrogen. Okay, four different hydrogen and four different carbon, but all of them are in same environment. Then there is two environment, because here is also H. Okay, these all H are in same environment and both of them are in same environment, so two environment. All of the benzene's hydrogen in same environment and remaining two are in the same environment. Here is one signal. Why? Yes, here is all of them are attached to the same carbon, and that is why all of the hydrogen will act as a single environment and will get one spectrum. Then here is two environment, because this hydrogen is added to bromide and this hydrogen is also added to the CH2Br. Okay, so this hydrogen will be more deshielded. Okay, so what is deshielding means, we will discuss this later. This will be more deshielded toward the bromide. Okay, but its nature would be different because it is attaching with the higher electronegative atom and there is no symmetry also. Okay, so there is three environment. Why three environment? Because this is having the very good uh, attaching with the bromide, then it is attaching with in a larger distance, then it is attaching with also in larger distance. Okay, so all of the environment will give three peaks. Okay, will have three peaks. So this is two environment. Why? Because just think about this carbon. So there is hydrogen, just I am putting the hydrogen here. So there is a hydrogen, this hydrogen is here. So this will be of one environment and other one environment would be these two. These two would be several similar environment. Then there would be four environment, because this hydrogen will have one environment because of the bromide. Then this will have another environment because what is attaching with them, one carbon, and here is one CH3 is attached with CH2. Then it will have another environment. Okay, then it will have another environment, four of them will have four environment. Okay, that means we will get four peak. Okay, we'll get four peak here. Then if there is symmetry, just think that there is another CH3 here, then what would be the environment? Then the environment would decrease. How? There would be three environment, like one environment, and there two would be similar environment, and the corner both of them would be another environment. Then here is two environment. Why? Because of their symmetry. You can see the middle one will have one environment and the remaining two will have another environment because of the symmetry. Here is three environment. Why? Because the overall benzene structure will have the same environment of hydrogen, because here is one hydrogen, here is one hydrogen in benzene structure, we know. Okay, all of them will have same environment because of the benzene structure, delocalized structure, and it will have another environment, it will have another environment. So the more environment, the more would be the peak in NMR. Okay, so we can easily understand the signals of number of the signals. Number of the signal means the environment of the hydrogen. Now we'll discuss on the position of the signals. So what type of hydrogen? Okay, so actually the position of the signal may vary from 0 to 12. This is the uh, range of NMR spectrum. So 0 to 12 it may vary a lot. Okay, it may, your peak may arise here, your peak may arise here, in different location your peak may arise. Okay, in different intensities. So actually chemical shift means how much it is shifted towards this x-axis. Okay, here is for example, here is 2, here is 4, okay, here is 6, here is 8. Just think, so how much shifting is occurring? This is called position of the signal. Actually it occurs due to the presence of some electronegative atom, or due to the presence of some heteroatom, okay, other than carbon and hydrogen. You can see for chloride you'll have peak on 3 to 4. For bromide you'll have peak on uh, uh, 2.5 to 4. Actually it depends on what? It depends on the nature. Okay, it depends on the nature of the electronegative atom attached with the carbon. So to make your understanding about chemical shift very clear, I have shown this. Here you can see the chemical shifting is from 0 to 12. So here in 0 you can see no electronegative atom. So this is called the upfield, this is called the downfield, this is called the shielding, this is called deshielding. Okay, this is for electropositive atom, this is for electronegative atom. Okay, so just think about methane. In methane structure, uh, the hydrogen is shielded by what? Shielded by the nearby hydrogen. So this is called shielding. Okay, and this is the upfield, and this is the this is for electropositive atom, because carbon and hydrogen are somehow electropositive, and this is kind of rule number 1 2 3. The position in 1 to 3, and their position would be like in value to that, like 9 10 11. Okay, 8 9 10. I mean their position would be very low, 8 9 10, like, or 5 6 7 for the heteroatom. Okay, just if you understand this easily, you can have better idea about the determination of the spectrum, or determination of the peak, or understanding about the chemical structure. Anyway, so this is for electropositive atom, and this means the shielding. What is shielding? Actually shielding means, you know your hydrogen is shielded by electron. Okay, your nuclei is shielded by electron. So this is very good. But think that if I provide uh, CH3Br, or if I provide a heteroatom with this structure, for example, this hydrogen is replaced by Br, or chloride, bromide, this is electronegative atom, then what would happen? Actually this bromide would, for its electronegativity, would take up the electron of what? Electron of the nearby hydrogen, and the hydrogen would get deshielded. You can see here, uh, whenever we have put a electronegative atom, so the electronegative atom will pull the electron towards it. Like you can see, oxygen has taken up all the electrons, and the hydrogen, there is no shield of hydrogen. Okay, hydrogen was shielded by the electron, one electron, yes. But whenever electron is pulling the electron, then it has been deshielded, and this is called deshielding. I think you have already understood it. Just remember all of these thing in a negative way, because these are for electronegative. Remember all of this for electronegative way. This is downfield, this is deshielded, all of them are negative what? Then this is the electronegative atom. And this is also true for some lower class, lower backbencher student, like whose rule number is 9 10 11 12 13, etc. And always remember this as positive thing, like upfield, shielded, and electropositive atom, and their rule number is look like 1 to 3, or their position would be 1 to 3. Okay, I think you can now easily understand then what would be the position of different compounds. You can see here your alkyl groups, there is no electronegative atom, so their position is on 1 to 3. So here, however, there are some also electronegative group, but the abundance of more carbon, okay, these are also good, their position are in where? Are in 2 3. Okay, suddenly we have increased the electronegativity. You can see fluoride, chloride, bromide, iodide, oxide. Okay, so their electronegativity, their chemical shift has occurred towards where, towards 456. Okay, then the benzene is very specialized because of its delocalization. Okay, so its position, always remember benzene's position is in numbers 7. Okay, 1 7, that means it is deshielded. Deshielded. Okay, then you can see the aldehyde. Oh my god, very electronegative atom. So aldehyde ketone would be positioned in 9 to 10. Then you have carboxylic acid, very electronegative. You know, there is two oxide, okay, two oxygen atom. So this would be very electronegative, and this would be very downfielded and very deshielded because its shielding has been interrupted by the oxygen. So this is the overall concept, and this is the shifting. Okay, so what is chemical shifting? What does chemical shifting mean? It means in the structure, if you provide some electronegative atom, then it would be shielded towards the uh, downfield, or okay, downfield. Then the chemical shifting will happen. So let's understand this clearly in the upcoming slides. So here is one environment, so no chemical shifting. One environment, no chemical shifting, just a type environment, no chemical shifting. But you can see here a chemical shifting. Okay, because of two environment. Whenever two environment has created, then it will cause chemical shifting. Okay, now you can see here is bromide. Okay, so this hydrogen will be very much aligned towards what? Okay, all of the hydrogen are in same environment, no problem. So it will have also one environment which will be very much in the third or fourth position, three or fourth position. Then come here, there is two electronic environment. So one is for B and another is for A. Okay, so what would be the shifting? The spectrum would be like that. Okay, so one spectrum would be like 0, and this is for 12. You will have two peak here because two environment, because of two environment. So where would be A, what one would be A, and what one would be B? Actually this would be B because this is very close to where, bromide, and this would be A. Okay, so how, that is how we measure the A and B. So you can also see here A, B, C, three environment means three peak. Okay, we have three peak. So which one would be in the downshield? The C would be downshielded, downfield. Okay, then B, then A, because this is the most electropositive here, and this is most electronegative because this is very deshielded, and because of the distance, the CH2 will have lower deshielding. So now you can also learn this by this mechanism. So here is the overall chemical shifting that I have shown earlier, has also been provided here. Just go through this. Then integration, that is that means the intensity also. I means intensity. So intensity means how much peak height would be. It gives idea about the how much hydrogen of each type. Okay, for example, just think here, there is two hydrogen, there is two hydrogen, and there is two hydrogen. So three environment. Okay, sorry, three hydrogen. So A is having three hydrogen, this is having two hydrogen, this is having two hydrogen. Okay, so it means how many hydrogen of same environment are available. You can see here we have two environment, these two are of one environment, and these two of, this one is for another environment. So for A environment we have 6 hydrogen, that means its height would be very high, and for B environment it has only one hydrogen, so its height would be very low. That means in the peak area, how we will define this, B would be like that and A would be like that. If you draw the uh, shifting of that from 0 to 12, you will have this, the chemical shift would be like that. So why its height is very high? Because of the hydrogen, it is having 6 hydrogen. So why its height is very low? Because it is having the one hydrogen. So another question may arise there, then why it is having the height in 0, near to 0? Because it is very in a distant way from chloride. Okay, but it is very closer to chloride. Same, you can have 12 hydrogen here. Okay, that means it would have a very sharp and tall peak. So 12 hydrogen here, but all of them are same environment. 6 hydrogen here, of same environment. There is two environment here. Okay, one is for CH3 and another is environment is for benzene. So for benzene 6 hydrogen, and for B it will have uh, 4 hydrogen. Okay, sorry, for benzene it would have 4 hydrogen, because here only 4 hydrogen. In the benzene you have 4 hydrogen, and 6 hydrogen is for methyl, 2 methyl group. So you can also understand this. There is 9 hydrogen, there is 3 hydrogen, 2 hydrogen. Okay, you can also see yourself what does it actually means. So how much hydrogen? Suppose it is chloride, so it is having two environment, A environment and B environment. For A environment we are having 2 hydrogen. Why? Because of the CH2. And for B environment we are having 4 hydrogen. Why? Because of the CH2, that means 4 hydrogen. Okay, so this information is necessary for upcoming peak generation. And our final information that we can get from NMR spectroscopy is the splitting pattern. So how many neighboring hydrogen are available? So the splitting occurs due to the neighboring hydrogen. Okay, so in general an equivalent neighboring hydrogen will split into n+1 Pascal pattern. Okay, for example, if you have nearby hydrogen of 0, then you will have 1 splitting. If you have nearby hydrogen 1, then you will have 2 splitting. Splitting pattern would be like Pascal. Okay, if you have 2 uh, nearby hydrogen, then you will have n+1 is equal to 3 splitting. Okay, so singlet, doublet, triplet, quadlet, quinlet. Okay, so we'll discuss this in upcoming slides. So n must be equivalent neighboring hydrogen to the give rise to Pascal splitting pattern. If the neighboring are not equivalent, then you will see a complex pattern. Okay, so how splitting pattern is performed? So we have already learned single environment, 12 hydrogen, and that would be singlet. Why? Because one environment. That would also be singlet because of the single environment. Single environment, singlet. Okay, so no difference. Now look at this phenomenon. Here is one environment, 9 hydrogen, but singlet. Why singlet? Because of the one environment. For one environment it will always be singlet. But think about this case. For two environment we will have multiple splitting. For this A, actually it depends on the nearby atom. Just think about A. It is having CH3, for which we have provided 3H, no problem. But the splitting depends on the nearby carbon atoms hydrogen. So for A, the nearby carbon atoms hydrogen would be what? Would be 2 plus 1, because of the n+1 rule. 2 plus 1 is equal to 3. So the splitting would be triplet. 3 means triplet. Again, if we consider about the B, then we need to think about the A for the splitting. So B is having 2 hydrogen, no problem. But how would be the splitting? Splitting would be depend on the nearby carbon's hydrogen, that is 3. So 3 plus 1 is equal to what? Is equal to 4. 4 means what? 4 means quartet. So for the B, your peak would be quartet. If I provide the spectrum here, then how it would be shown? Okay, for B, what would be the position? For B, the position of the splitting would be in towards 12. For B, we will have a peak like uh, so quartet. How it is drawn? It is drawn in that way, like that, like that, like that. So quartet is drawn in that way. So for A, which environment will have a triplet. So how triplet is drawn? Triplet is drawn in that way. So you may think that why my peak height is for A is higher. Actually, peak height depends on the 3H. For 3H, 3 hydrogen, we have a very high peak height. Okay, so the peak height depends on this, but splitting depends on what? The splitting depends on the uh, you know splitting depends on triplet. Okay, so this is the overall concept. You can also understand this. for example for A. So how many nearby carbons hydrogen it has? 2 plus 1 is equal to 3, triplet. Okay, no problem. For B, so it has two corresponding uh, carbons hydrogen. One is 3 and another is CH2. So 3 plus 2 is equal to 5, and 5 plus 1 and plus 1 rule is equal to, it would be 6. That means that would be 6-let. Okay, so this is very complex. For 6-let it is very complex, but think about C. So how would be the, what would be the splitting based on its nearby carbons hydrogen? That is 2 plus 1 is equal to 3, triplet. So you can easily understand now how singlet, doublet, triplet, quadlet, okay, quinlet or 6-let is performed. Just practice this yourself. I think you can easily understand this. Also you can see here there is two environment. So two environment means A. So nearby carbons is 2 plus 2, 4. That means 4 plus 1 is equal to 5. So 5 means what? 5 means quintlet. So that would be uh, quinlet. And think about these two carbon environment, the B, 4 hydrogen, okay, but it would be triplet. Why triplet? Because CH2, 2 plus 1 is equal to 3. Now if we look at the spectrum, then how it would be shown? First of all, cyclohexane. So in cyclohexane, singlet, one environment, because all of the carbons are similar environment, singlet, and 12 hydrogen. So 12 hydrogen means very sharp peak. Because why it is very high enough? Because of the 12 hydrogen. So if it would be for 3 hydrogen, then its height would be like that. 2 hydrogen would be like that, but it is having 12 hydrogen, so it's very sharp peak. Okay, then singlet, so no splitting occurs. And also see its position. Its position is very near to 1 because there is no heteroatom, only carbon and hydrogen, so its position need 1 to 2. Okay, now look at 2,3 dimethyl 2 butane. I have also already shown this. Singlet, 12 hydrogen. Okay, then benzene. So benzene is very special. I have already told about that earlier, that benzene will have a singlet at 6 hydrogen. Okay, so 6 hydrogen means very sharp peak. The singlet means will have one peak, one environment means one peak. And its position, look at its position, 7 to 8, because I have already discussed this, because of its anisotropic effect, or its deshielding or a delocalized electron. Actually its position is in more downfield, okay, towards 7 to 8. Now look at paraxylene. So it's related to benzene. So whenever benzene's spectrum or benzene's NMR spectrum is needed, then its position would be within 7. Okay, now I think we can easily understand why it is 7. Singlet, B, for B it is singlet, and its position is 7, height would be 4. So just put the scale. If you put the scale, it height would be 4 and it height would be 6. Okay, then look at the CH3, it would be singlet. Because of what? Because of the uh, all the benzenes hydrogen are in one environment. So okay, it would be singlet. Then tertiary butyl bromide. So singlet, 9 hydrogen. So why 9 hydrogen? Because uh, there is 9 hydrogen, and it would height would be very higher, and its position is would be in 1 to 2. Now ethyl bromide, I have already shown this. One would be triplet and one would be quartet. So one would be towards the downfield, one would be the upfield. So which one would be upfield? A would be in upfield, so this is A, and B would be quartet and it would be B. So it is triplet, so 3, and it is quartet. Okay, also look at their height. Its height is 2 and its height is 3. Because of what? Because of the intensity. Then one bromopropane. First of all, 3 peak you will have. Okay, so how much how would be their position? So A, B, C, that means A would be here, B would be here, C would be here. Okay, is understandable. Then for A we'll have triplet because of the nearby 2, so there is triplet. Okay, for B there is sixlet. We have already shown 6 splitting will occur. You can see, just count this, there would be 6 splitting, 1 2 3 4 5 6, 6 splitting. And another one is triplet, so here is triplet. Okay, for C. Now this is for isopropyl chloride. So isopropyl chloride means one environment, and this is for another environment. But for B it will be toward, this is for B. Why? Because it is very aligned to the chloride, and CH3 is far away from the chloride. That is why it will be in upfield. Okay, so for A we will have doublet. So there is 2 peak here. Okay, but its intensity will be very high because of 6 hydrogen. Its intensity would be 1. Suppose it is 1 inch and it is 6 inch. Okay, but it would be septate. Why septate? Because of the 6 hydrogen. You know, 6 hydrogen, 6 1 plus 1 is equal to 7, so it would be septate. So it is actually, if you zoom this in, if you zoom in, you will find out that there is 7. Okay, so how, if you zoom this, you will find that, you'll see that in that way. So 5 6 7, so septate easily, if you zoom this out, you will find this. Okay, septate is drawn in that manner. Then 2 bromobutane. So how it is measured? Look at this. First of all, for environment A B C D. Okay, A, then B C D, B, then C, then another one is D. Actually D's location would be in here. Okay, so there would be D, and this is C, this is C. Sometimes some of the peak integrate with one another. So for C, how much would have 5. Okay, complex means that is quintet actually, so 5 splitting would happen. Okay, here is actually 5 splitting. For B, doublet, so you can see the doublet, but its intensity is high for B because of its height. Then A and D. Now the D's height is very much smaller because of one hydrogen, height is smaller, but it has how much nearby carbon, nearby hydrogen, 5. 5 plus 1 is equal to 6, that it be 6 let. That means it is splitting into 6. Then look at this, orthomethyl benzene chloride. So it is one environment, it is another environment, and the full benzene hydrogen would be another environment. There is 4 hydrogen here, 1 2 3 4, because there is no hydrogen in that linkage, because hydrogen has been substituted. So 4 hydrogen, so 4 hydrogen means that would be singlet because of one environment. So why all of them has is singlet? You need to understand this. These are singlet because of the benzene's environment. Okay, so for this case, all of them would be singlet. This is singlet, one sharp peak, one sharp peak. But the position, look at the position. B, the position of the B would be higher. The position of the B would be very much closer to here. You know, the 7 would be for what? 7 would be for C, because C will always have this position. And another one is A. This is CS3. As it is CS3, you know, CS3's location would be within 1 or 2, but it is outside of 2 because it is attaching with the aromatic. Okay, aromatic ring. So ABC would be like that. Then ethanol. So this is very interesting because here is 3 hydrogen. 1 is here, 2 is here, and 3 is here. So for a hydroxyl, I have already shown that its location would be within 4. Okay. So for A, we have triplet because of 2. Then for B, we have how much nearby? For B, there is no nearby atom, because look at this structure. Its nearby atom would be oxygen. So for B, it would be singlet. So why singlet? Actually no splitting would occur because it is attaching with the with no carbon, it is only attaching with the hydrogen oxygen. So for B it would be singlet. But look at uh, C. For C, how much nearby hydrogen it have? It only have 3 nearby hydrogen. So 3 plus 1 is equal to 4, that means quartet. So why we didn't take the hydroxide into consideration, the hydrogen? Because it is attaching with the oxide oxygen. Okay, so look at there also. So for hydroxyl, so these would be for B. Why? Because very electronegative. Then would be CH2 is attaching, so that would be for C and that would be for A. So why A is having very high height? Because of the CH3, 3 hydrogen. So its height would be 3 times than that. Okay, so that is 1 height, that is 2 height, that is 3 inch height. Just suppose I put the unit 1 2 3, their height would be 1 meter, 2 meter, 3 meter, like that. Then ethyl benzene, all of that will have one environment, these will have one environment, it will have another environment. So A, B, C. So how I'll arrange them? Always the benzene would be C and its location would be in 7. Okay, very good. Then CH2, CH3. So which one would be CH2? CH2 would be B. As it is near to the benzene, then its location would be like that, and the remaining one is A. Now look at their height. So it's having very high height because of 3 hydrogen. Okay, and you can say the B only 2 hydrogen, so this height, lower height. And you know here 5 hydrogen remaining, so it would be sharp because of 5 hydrogen. Okay, its sharpness is height is increased. Then here would be one singlet, you can say one sharp peak here. Okay, this is called singlet. You can also see a lot of peaks here. This is absolutely true for aromatic ring because we have some deshielded delocalized electron and proton, you know, that is why it has some noise here. Okay, but the overall peak is singlet. Then quartet. Why quartet? Because don't keep this into consideration whenever we are analyzing the aromatic ring. Just keep the aromatic ring aside. Okay, now look at the B. How much nearby atom? 3 nearby atom. So 3 means what? 3 plus 1 is equal to 4. Quartet. So that would be quartet and that would be triplet. Then para diethyl benzene. So how much environment here? So, this benzene is one environment. Obviously it could be here. Obviously it will have 4 hydrogen. Okay, so benzene is having 4 hydrogen, so that would be always be singlet, nothing to say. And this is a position would be 7. So benzene's characteristic is like that, nothing else. Then look at the similar one. So B, these are having the B environment. So B has how much hydrogen? 4 hydrogen. Okay, so B has 4 hydrogen and A has 6 hydrogen. Okay, so how much nearby we have? Now look at that. You have to keep the consideration into one, any one. So if I take the consideration of B, the CH2, just you have to think about one. How much nearby atom? Only 3 nearby atom. 3 nearby atom means 3 plus 1 is equal to what? 3 plus 1 is equal to 4. That would be quartet. Always keep in mind that don't count the full. Don't count the both of them. This is the rule. Okay, same for A. Don't count the CH2 CH2, just count on one CH2 because both they are symmetrical. Okay, if they would not be symmetrical, then we can take this into consideration, but they are symmetrical, that is why we count in that way. Then 2 bromo 2 methyl butane, this is also understandable. You can see how much environment it has. It is having one environment, then it is having one environment. Just think about this carbon. These 2 methyl are in one environment, so these are B, these are A, these are C. So A, B, C. Okay, I think you have understood. Then so where would be their location actually? Okay, so their location would actually depend on what? Would actually depend how much aligned with one another. Okay, So B and C is having similar spectrum. One is quartet, another is singlet. Actually, the B and C is here. Why? Because their peak has integrated. Because both of them is showing their location, where showing their location in 1.7 or like that. That is why the singlet and quartet, okay, singlet and quartet has aligned with each other. So this is the singlet, you can see this is the singlet, and this is for B. But where is C? C's location is in here. And A, obviously A is outside here, because is the most electronegative, I mean least electronegative, okay, because of its distance. So I think you have understood this. Now practice another one, di and propyl ether. So this is also symmetrical. Symmetrical means how much environment? A, B, C, three environment, and these two would be symmetrical, these two would be symmetrical, okay, these two are also symmetrical, but three environment. So whenever you are counting the total hydrogen, obviously they would be counted based on their availability. So for C, how much hydrogen? 4 hydrogen. For B, how much hydrogen? 2 plus 2 is equal to 4 hydrogen. For A, how much hydrogen? 3 plus 3 is equal to 6 hydrogen. But whenever you are thinking about the splitting, obviously don't put one side, just consider one side, okay, whenever you are talking about splitting. So now for A, how much splitting will happen? For A, nearby hydrogen is 2, so 2 plus 1 is equal to triplet. For B, how much nearby proton is has? It has 3 plus 2, 5 nearby proton, that means it would be 6 let complex, 6 let means complex. Then for C, how much nearby hydrogen it has? It has only 2 plus 1 is equal to triplet hydrogen. I think you can easily understand that. ABC. So how would be the location of the ABC? A is in most distant from the electronegative O. So A would be this, B would be this, and C would be this. I think you can easily understand this. Okay. So methoxy group or hydroxyl group would be location in where? Near to the 4. Okay. So C is in here. A is in here. So why their height matters? So you can see for 6, A height would be 6 time, okay, C's height would be uh, 4 time, okay, then B height would be 4, okay, but as it has been splitted a lot, you can see 6 that is splitted, that's why it height would be decreased. For example, if I had this pattern, but if I tell you that please split this into different way, then whenever you are splitting this into 2, it height would be like that. Whenever you are splitting this in 3, then it height would be like that. Whenever you are splitting this into 4, it height would be much more smaller, and this thing happened to B. Actually B's height should be as like as C, but it has split it a lot. That's why whenever, just keep in mind that whenever something would be 6 uh, sextet or septet uh, splitted, then its height would be automatically decreased. Then think about the propanol, propanol. So A, B, C, D. Okay. So A would be here, B would be here, C would be here, and D would be here. And D is the hydroxyl, and hydroxyl location is in within 4. Okay. So think about the nearby one, 3 hydrogen, 2 hydrogen, 1 hydrogen, 2 hydrogen. Okay, and think about the splitting. Think about B. How much nearby atom? Nearby hydrogen is 5. 5 1 is 6. That is 6 stat. That means it is would be splitting into 6. So there is 6 splitting here. Okay. So actually, I think you can now easily understand that how it can be calculated. You can also practice this yourself. So just practice this as usual. Here is another structure. Now you can see 1 environment, 2 environment, 3 environment. So for benzene it is here, for hydroxyl it is here, for CH2 it is here. Now you can easily understand. I think you can easily check the structure now, and if I give you some solution, you can easily also perform uh, the overall structural integration or structural elucidation. Still, if you have any confusion, please inform me in the comment section, and the remaining portion, the principle, the instrumentation, and the overall application, and the basic mechanism or quantum mechanism, towards the NMR spectroscopy has been given in the upcoming video. Thank you.